Hey, this is the video where I will explain to you the study guide that you need to do, and then I'll also do a couple problems in the 3.1 to 3.4 packet as well as telling you which ones are optional. So the first thing I want to discuss is the study guide. In Schoology, I have a little bit of a guideline for it, but honestly, the study guide is for you and what will help you do well on the test. I do make it worth 20 homework points for everybody, so it is due the day of the test for 20 points, but it's a competition as well. So in each hour, I'm not sure if I'm going to do the top 4 or the top 3, but extra percentage will be added to your test grade. So if you go in here where it says study guide, y'all, and if you were to click on it, I give you what I have to have on it. And I can do a handout of this too, but you need to discuss how to find critical numbers, values, points, not ponents, of a function. So you will tell me how you find critical values, critical points, and then provide an example. So each one needs to have an example with it. You will then explain how to find absolute maxes and mins, and then provide me with an example. You'll then explain to me how you determine if a function, so everything is going to be in words first and then a concrete example. Those examples can come from homework. I kind of prefer they don't come from notes, but they could, but that wouldn't be very clever. But you can do examples from homework, from notes. I actually prefer that you at least do the math in pencil. I like you to go brain to pencil to paper. So if you want to type in how you find critical numbers and values and explain on a Google Doc, then leave some space for you to handwrite the example in. I don't want you typing the examples. That won't get you any extra points, and I'll probably bump you out of the top 3 or 4 because I really like it to go from your brain to your pencil to the paper. So for each one of these items is what I'll be looking for, and you're going to number them, but I'll get to that later. You're going to tell me how do you use the first derivative test to find relative extrema. You're going to explain to me, like write the steps down and how you would go about doing that, and then you're going to give me a good example. Now, your examples could help bump you into the top 3 or 4 in the class. If you're doing the exact one in my notes and picking the easiest one, probably won't get as much cred as the person who maybe does one of the harder ones from the 3.1 to 3.4 packet or one of the harder ones from the homework. Could you get a 20 out of 20 by just doing all this and using the examples, the easiest ones from your notes? And the answer is yes. Will you be in the top 3 or 4 and get extra added to your test? Probably not. You'll discuss the second derivative test. Again, you don't know that yet, so there's a few things here you won't be able to do yet, but Friday we're going to try to wrap up 3-4, so should be able to do everything by Thanksgiving break. Next, it says make sure you discuss the difference between these two tests. I really want to make sure that on your study guide you're very clear what the difference is between the tests, because historically that's something that gets causes issues on the test. So anyway, some of this you don't know yet, but these are the things that I need to see. I'll be looking for 11 things. For each of the 11, you're going to give me an example. You can type if you want, but again, all the examples I want done in your handwriting. If you're choosing the easy examples from your notes, you could totally get 100% on the assignment, but you probably won't be in the top percentage. So it says, how do you get 20 points on this? Because it's 20 out of 20 on a homework score. Turn all 20, you must discuss all 11 items, include an example and an illustration. What does that mean? It means I need a sketch. I want to see what's happening. If you're doing the mean value theorem, I want you to explain with a sketch what it says. You must separate and number all 11 items. If it just looks like a big random list, you won't get full credit. So I need to see number 1, whatever number 1 was up there, critical values and critical points. Explain to me how you find them and what they are. Give me an example and an illustration. Then, boom, number 2. All right, so make sure you designate each one, because it's hard to grade if it runs all together. So you won't get the full points if it's just a random mess. So separate and number all 11 items. There are samples up on the front table for you to look at, but don't take them with you. To be eligible for the winning test percentage bumps, 4, 3, 2, 1 in each class, so the top 4 in every class will get a bump, you would also need to add to yours a related rates discussion. You must have some color, like it can't be all done in pencil. Again, that's just to be eligible. You can do this all in pencil. You don't need to discuss related rates. And there should be something unique about its aesthetic. I've had people do flip charts, or I don't know, use just something that's different than written in pencil on notebook paper. All right, so, and we'll discuss that a little bit more on Friday, but for those of you who wanted to get a little bit of a head start, I wanted to explain the study guide to you. The next thing I want to do is go over a couple from the packet and tell you which ones you are allowed to skip. So back to our folder. You should now take out your 3.1 to 3.4 work packet. If you weren't here yesterday, it's up on the front table. Or sorry, if you weren't here on Tuesday, I guess. If you weren't here on Tuesday, you should be watching these videos. And where is it? The big packet. I'm going to log into the key for a second. I give a full worked out key to this one because it's got some meat to it, a little bit more rigorous than the book work was. So I'm going to log in here. First of all, I'll tell you which ones are optional. So if you go through, there's a couple of them where I write level 5 problem. When it says that, you don't have to do it. All right, so here's one right here. Number 3 on the second page is a level 5 problem. This is optional. I actually think we did this one or one really similar in your notes though, so you might want to opt in on that one, but you don't have to do it. The next one that's optional is this number 6 on the, where did it go? Number 6 on the MVT one, okay? Also a level 5. Actually, this is the one that we did in our notes. You should be able to do that, but it's optional for number 6. Let's see what else is optional. I believe there's one more. Paging through. Yeah. I'm just looking, I think there's one more that says optional on the key, and actually somebody just stopped by. So we'll be doing this number 5 in class, so if not, I'll make a video of it. So that's kind of on hold too. Trying to scroll here. And I guess there's only 2 that are optional right now. And what I'm going to do right now is go in and do a couple of them with you. So you can go ahead and I'll circle the ones I'm going to do, but then I'm going to have to go to a blank sheet of paper. So on the first page, I'm going to do this one with you. 4C. I think there's one above it too I want to do. Yep. All right, so I'm going to do 3C, and I'm going to do, sorry, it's very temperamental when I'm scrolling here. So 3C for sure, and then 4C. So 3C and 4C I will do with you, so have your pencils out. Then I'm going to do a mean value theorem one, so I'm going to skip a little bit. Again, just copying this whole key, you'll get full credit on the homework, and the test will not go very well. I'm also going to do this one, number 5 on the mean value theorem. And then I might do a related rate as well. So I'm going to get some blank paper so I can go ahead and do those with you. Then when I'm done, you can keep working. So I said, first one I was going to do is 3C, finding the critical values of a function. The function in 3C is g. It's defined as 5t to the 2/3 power plus t to the 5/3. When I'm looking for critical values, the first thing I do is I take a derivative. So I'll say g prime of t is equal to, I bring the power out front and I get 10/3. I knock the power down 1. Similarly over here, I bring the 5/3 out front, I knock the power down 1, disguised as 3/3, and I get 5t to the 2/3. We like to get our negative exponents in the denominator. Can leave it as a radical, or exponential like that, but the t to the 2/3 is on the top. So this is my derivative. Remember, a critical value occurs anywhere where the derivative equals 0 or does not exist, but before I can determine that, I need a single fraction. So know that you can't decide that when you have a sum or difference. You need a single fraction. You know, it's always safe to crisscross applesauce. I think on the key, I recognized that these both had a 3 in it, so I just multiplied the one over here on the right by t to the 1/3. But honestly, if you just do the criss plus the cross, this would be 15 t to the 2/3 times t to the 1/3 is t to the 3/3, or just t, and then multiply across. This will serve its purposes just fine. It's just a pumped up version of the actual derivative. It's just got some common multiple in there, but the zeros will be the same. So this will look a little different than the key, but I need to know where the derivative equals 0. For that, I just focus on the top, which would be at t equals -2, or where the derivative doesn't exist, and for that, I look at the bottom. So these provide me with my critical values, and that's all it says. So the critical values are just the x coordinates, in this case the t coordinates, so I'm done. The next one I wanted to do with you is for C. I'm finding absolute extrema. So I have my derivative, my function defined like this, and I'm being put on a closed interval from A to B. Remember, for absolute extrema, you immediately make a candidate table for x and the y value at that x. We immediately put in the endpoints. We can have an absolute max or min at an endpoint. I then evaluate the function at that endpoint. So I'm going to go put -4 into the function. It'll be -4 squared minus 4 over -4 squared plus 4, which gives me 12/20, and it looks like 3/5. I'll get the exact same answer when I plug a 4 in, since I was just squaring it, so I don't need to do that. So the height at the endpoints is actually at the same height. It's at 3/5. Then I need to find all critical values. The only way I can take the derivative of this is to use the quotient rule. So I go low, d high, minus high, d low, draw a line, and I square below. And I know I did that fast, but it's just low d high minus high d low, draw a line and square below. Remember, I need to add critical values to my table. That's anywhere where the derivative equals 0. I'll focus on the top. And because this has a denominator, I also need anywhere where the derivative doesn't exist, which I'll focus on the bottom. Now the bottom can't be 0. No matter what I put in and square it and add 4, I'm going to get a positive. So there's no way I can get, this is positive right here. It's greater than 0 for all x. So I don't have any places where the derivative doesn't exist, but I still need to look at that numerator. I have 2x to the 4th, and then I have plus 8x. And then I like to put this out front, so I make sure I grab that negative. So, sorry, that's 2x to the 3rd. And then I have a minus 2x to the 3rd, and then it looks like a plus 8x. That's my numerator. I need to know where that's equal to 0. So the numerator of my derivative, if I were to rewrite my derivative, it's actually 16x over x squared plus 4 quantity squared. My critical values occur where the derivative equals 0, meaning the numerator equals 0. That adds the critical point to my table. The denominator can't be 0, so that doesn't add any more critical values to my table. I now just need to figure out the height of the function at 0. So I go back and put it in here, and I get -4 over 4, or -1. So the question is, what are the absolute extrema of f? I have a max of 3/5 at x equals plus or minus 4. Right here, they were tied, so they're both considered absolute max. And I have an absolute min of -1 at x equals 0. So that one's done. The next one I wanted to do with you was the MVT one. And I want to do MVT number 5. So kind of page through to the MVT section, it'll be 3.2. We're going to look at number 5. G of x equals x plus 1 over x on the interval from 1/2 to 2. It says determine if the MVT can be applied to the following function on the given interval. If so, find the values guaranteed. So the first question, to apply it, I have to verify that it's continuous. G of x is continuous on 1/2 2. There's a discontinuity at 0, but that's not in the interval. I don't know if it's differentiable yet on that interval until I take the derivative. So before I do the differentiable part, I'll go take a derivative. A couple ways to do that. I can either do quotient rule, or I can do, if it makes a heart, break it apart. I think most of you do the quotient rule though. So let's go low d high minus high d low, which is just 1. Draw a line and square below. My derivative is x minus 1, so it looks like I have a -1 over x squared. My derivative actually does have an issue. It's not differentiable at 0, but again, 0 is not in my interval. So number 2, I'd say g of x is differentiable on the open interval. All right, so it did have a continuity issue and a differentiability issue, but they were both at 0, which is outside of the interval. So what that means is I can apply the mean value theorem. What does it say? It says that the slope of the secant has to equal the slope of the tangent at least one place. Slope of the secant is f of b minus f of a over b minus a. The tangent is the derivative. I then need to go do f of b minus f of a. That's arithmetic, so let's go do that. F of 2, I have to go back to the original function. F of 2 would be 3/2 when I put a 2 into the red g of x. So I'd have a 3/2. And you guys can do the arithmetic, so I'm just going to, and then f of a half would be 3. And then it's all over 3/2. That would have to equal -1 over x squared. So on this one, when I do 3/2 minus 3, I'm going to disguise that as 6/2. I actually get -3/2 on the top over 3/2 on the bottom. Just doing some fraction work here. That's a -1. In order for -1 to equal -1 over x squared, that would imply that x squared would have to equal 1, which in turn would imply that x would have to be plus or minus 1. Well, then I go back to the interval in question, and I realize that -1's not in there. So -1 is not in my solutions, and I would say you can call it C or X, but +1 is the only solution to this question. So that one's done. And I think I'm going to quit right there. I was going to do a related rate, but I also want you to just be able to work on this. So that's it. You will continue working on this. You go back up and get as far as you can get in the time given. Have a good one.